Hey guys, all right. So today what we're going to talk about is something that you probably haven't been exposed to previously, and that's what we call force transfer in skeletal muscle. Force transfer is something that many people don't really understand or discuss because it's a little bit more complex and a little bit more maybe esoteric, but it's really important for injury prevention, and it's really important for how our muscles work. So by the end of this series of videos, you should be able to describe what force transfer in skeletal muscle is. You should be able to define what we call rate of force development, so how quickly we can develop force. And that's and what I'll show you is that's one of the best measures of strength and power and speed. You should be able to name a key protein in longitudinal force transfer. That's force transfer along the line of the muscle fibers. And then describe how one single nucleotide polymorphism affects this protein and how we think that that alters performance. You should be able to explain how much force is transmitted laterally. So lateral force transmission goes from the center of the muscle fiber to the outside, whereas longitudinal force transmission goes from one sarcomere to the next sarcomere to the next sarcomere. And I'll show you that. And then you should be able to explain this important protein, dystrophin, and what happens to muscle and what happens to force transfer once dystrophin is lost. You should be able to name a force transfer protein that is decreased with age and describe a microRNA that plays a role in this regulation of age-related loss of that protein and how that can affect injury rates as we get older. All right, so what we're going to do is we're going to start with force transfer. So what we've always taught you is we've taught you a lot about this thick filament and this thin filament. So we have actin in the thick filament thin filament and myosin in the thick filament. And those are your motor proteins. Those are the things that are going to go through, and you're going to do the cross-bridge cycle, and you're going to do all of that whole thing. But if those things are just pulling and there's nothing around it for us to get the force to the ends where we got tendons and bones so that we can move, it's really not useful. And I always give the analogy here of if you've ever gone up to Tahoe after really big snow and there's a ton of powder, and if you fall down and you go to try and push up to get up, what you find is that you can't actually push up because there's nothing to resist. There's stuff around you, but because it's so powdery and fine, it doesn't resist your weight. And so what you have to do is you have to pack it down. So that's essentially what we're doing when we talk about all of the stuff around the motor proteins. Our body is the motor protein in that example. You go to push or you go to pull on that powdery snow, nothing's going to happen because there's nothing to pull on. So you have no attachment to the environment. Now what happens after you pack it down, after you change it, what you're going to find is that when you do that, you're going to get into a situation where now you can actually produce force and transmit the force from the motors to do what you want to do. So what we've got two types of force transmission through a muscle. Longitudinal is the kind of thing that we think about all the time. You've got two tendons at the end, we see them shorten, so what we think is happening is each sarcomere is shortening, and as each sarcomere shortens, the two tendons get closer together. That's the longitudinal force transmission. It goes from sarcomere to sarcomere to sarcomere to the tendons to the bones to cause movement. By contrast, one that almost nobody really thinks about is this one called lateral force transmission. And here what happens is the muscle fibers here, or the myofibrillar proteins that are producing force, are contracting, pulling on this matrix. What we have to do is we have to actually connect that to the fiber that's over top. So what you don't want is you don't want one muscle fiber to be contracting while the other muscle fiber is still. You have to link these things together so they work together as a unit. And that's going to be really important. This lateral force transmission is what we're going to talk a fair bit about in these series of videos. And what we're going to find is that 80% or more of the force is actually transmitted laterally, whereas, what we're going to say is about 20% of it's going to go longitudinally, but really it's this idea that we transmit force laterally so that all of the whole muscle can work together, so you protect each individual muscle fiber from injury, and you link all those muscle fibers together so that the whole muscle works better.